Hello guys, 9A4 Queen Victor here. In the last video I showed you how to use the Adalm-Pluto and Harmonic mixer, the Alcatel power detector, to observe the frequencies above the 6 GHz. And in that video I used some components, they were flipped over, and then I received lots of emails and questions and also some comments below the video. What is the magic behind the green PCB and why the PCBs are flipped over? So I can show you the magic. If this is the magic for you, then okay. There are two reasons why the boards were flipped over. The first one was the simple one, because the top side, the upper connector going outside, actually was on the close to the receiver side of the Adalm-Pluto, so it was easy to connect it properly. Not like this, you know, I have to bend the cable, and this is not okay. And the second reason was obviously design of the duplexer, and the design is not proper, and this is not for everybody. If you don't understand the basics of the low pass filter, you can make a lot of damage, and then it will be my fault. So what is going on? This is the basic schematics of the harmonic mixer with the Adalm-Pluto. The TX is going to the small PCB. It's just the mimic board with the SN8 586, the same as ERA 5 SM. And then the output is going to this duplexer board. It's just in series capacitor and the low pass filter going to the RX side. And then this point is going to the Alcatel power detector. In theory, this low pass filter, the response should be like this. So we have the cutoff, and then we have attenuation after the cutoff frequency. But the true story, the rest of the story, is this. This is the span from 100 MHz up to 5.9 GHz. And of course, we can observe the cutoff, but also a region where there is no attenuation at all. This is around 4.8 GHz. So where is the problem with this design? The problem is if you run the Adalm-Pluto. So this is the Adalm-Pluto. I packed it in the aluminum 2.5-inch hard disk casing to have a better isolation. So if you're running the oscillator, your main oscillator, so the takes port, on the 4.8 GHz, your low pass filter will pass this frequency to the RX side, to the receiver. And you have the amplifier here producing around plus 15 dBm, and you will run almost 15 dBm to your receiver side. Obviously, you will burn your receiver side. If you don't measure your simple duplexer that I made, you may run into problems. So this is why I didn't show you the duplexer. The proper design should be different, and even this one can work, but not with lumped elements. The microstrip line filter should be used, and then we should avoid the problems like this one. We should have a proper low-pass filter curve, like closer to the theory. So now you have all answers on my previous video, and hope you will make a good duplexer, not the bad one as I have here in this example. So that's it. Thank you very much. 9A4 Queen Victor.